Hello students, this lecture will be on integral. So we will face with definition, formula of calculation of integrals, and then how to find definite integral or the formula of indefinite integral, and how calculate double integrals. So in mathematics, integral assigns volumes to functions where we face with infinitesimal data, and this process of finding integrals is called integration. So let's go to the formula, and we can see that this is the controversial process of integration and derivative. So this is called the function of integrals is antiderivative of first function. And this is the formula for finding integrals. As you see, I'll get an example for this. So if we have to calculate any of integrals, now it's indefinite integrals without bounds or limits. So we can see here, put it like that, x in 2, so it will be x in exponent 2, and it will be so we can get from this formula that it will be x in exponent 1 plus 2, and dividing by exponent 2 plus 1, and this is the final result of our calculation. It will be x in exponent 3 dividing by 3. So if we deal with definite integral that have bounds or limits like a and b, and then we calculate by some rules when we disclose the function, and then calculate the values of function from b, and then we destruct the values from values of function from a, other bounds. And we have some, if we have some constant inside of this integral, we can put it out of our calculating and make calculation with integrals, and then we multiply by this constant. And if we have the complex function that we deal with, we can decompose it by integral, and then we calculate this complex function by parts of this function. Let's go to examples. So if we have to calculate integral with bounds like 1 and 2, we first of all put the constant out of our calculation. It will be like that. And then we put our sign of integral. This means summa in Latin language. This is s, and then our two bounds, and then other part of it, and then we're just cloning it by, it will be like that, and then we have, as was shown previous part of flexion, and then we make this and pull bounds like that and that, and calculate all these for 2 by 3, and then we can make it like that. The higher bounds of 4 minus the lower, the less, and then we see that it will be 40, and it will be like that, 4 and 2 divided by 3. This is the end of our calculation. So if we have complex function and have to calculate integral with bounds, definite integral, so we decompose this function by parts. It will be like that. So we decompose it by parts, and then we calculate the integral. Eight multiplied by first bound of 4 minus second minus 2, then plus 4 in exponent 2, and by the way we reduce this, and then it will be the second part of our decomposing function, minus 2 in exponent 2, then the third part of it, it will be and 4 in exponent 3 minus 2 in exponent 3. get here double parenthesis here. So we get first of 8 multiply by, here we get 6. Then we get here, it will be 16, and then here we have 2, and next one to it will be 4. And the third part will be minus 1/3 multiply by 4 plus 8, and it will be, so it will be 48, then plus 11, then minus 1/3 multiplied by 72, so it will be 4. So we have 60 minus 4, and it will get us to our final results. That will be 36. This is the end of our lecture on integrals. Thank you for your attention. Goodbye.